Okay, you right? Let's go through the solutions for our mental maths. 3 times 7 is 21. 32 divided by 8 is 4. 1 times 5 is 5. 50 divided by 5 is 10. 10 times 5 is 50. 120 divided by 12 is 10. 9 times 11 is 99. 77 divided by 11. 10 times 7 is 70, and 1 times 1 is 1. Next one. 3 minus 1 is 2. Minus 3 minus 4 minus 7. 1 to the power of 1 is just 1. Square root 9 is 3. Alright, underneath the square root, 46 minus 10 is 36. Square root of 36 is just 6. Alright, prime factorization of 54. Let's come over here for some more room. So we've got 54. Let's think of two factors of 54. How about 9 and 6? 9 times 6 is 54. That can still be broken down into 3 times 2 is 6, and 3 3s are 9. In other words, 3 to the power of 3 times 2 is the prime factorization of 54. 3 times 3 times 3 times 2 is 54. Alright, highest common factor of 40 and 90. In other words, the biggest number that fits into both, 10. Lowest common multiple of 4 and 9. That would be, when you multiply them together, 36. 5 equals something over 7. 35 divided by 7 is 5. Different denominators, so let's make the same. 70, 70. So you end up with 53 on 70. Alright, straight across the top, straight across the bottom, 12 on 55. The next one we do KFC, keep, flip, change. So keep the first fraction, flip the second fraction, and change the sign. And let's simplify first. So 3 fits into 3 once, and 3 fits into 9 3 times. So that's 3 on 12, or 1 on 4. Okay, rounded to 1 decimal point. So that's the first decimal point. So look at the second. Is it 5 or bigger? Yes. So 6.9. Alright, here's your invisible decimal point. If you're dividing by 100, move it 2 spots to the left, 0.69. 7 on 25 has a percentage. To get a percentage, you need the denominator, the bottom number, to be 100. 25 times 4 would be 100. So times the top by 4 and you'll get 28%. Okay, let's add our tenths column. So we've got 0.8 and 0.6. That's 1.4. So 5.45. You can also do it as a vertical algorithm if you like. Just make sure that your place values line up. Alright, let's do this one as a vertical algorithm. So we've got 0.86 times 0.2. Alright, 2 times 6 is 12. 2 times 8 is 16. Add 1, 17. And 2 times 0 is 0, add 1. Now put a 0 down. 0 times 6 is 0, 0 times 8 is 0, 0. So let's just fix that up. Okay, going back to number 27. One way of doing it is moving the decimal point 2 spots. So you'd have 86. You'd need to do the same for the second part. 1, 2. So you'd have 20. 86 times 20, or in other words, 86 times 2, which would be 160, 172, add a 0. Now, going back to your question, how many digits are there behind the decimal point? There's 1, 2, 3. So 1, 2, 3, that's where your decimal point goes. 1.72. Move your decimal point again, 2 spots for both. So 14 divide by 4. How many 4s in 14? Well, there's 3 4s in 12 and 2 out of 4 left over. 2 over 4 is the same as a half, so 3.5. If x is 50, 50 on 10 is 5. Oops, sorry. And 5 eighths are 40. 40 divided by 8 is 5. Alright, coming down to step 2, still not using a calculator for this one. Alright, minus 3, minus 4, minus 7. Two negatives make a positive. So minus 4 plus 1 is minus 3. And when you see a negative and a positive next to each other, the negative wins. So it's 1 minus 6, minus 5. Two negatives make a positive. Alright, there's an invisible 1 here. So we add the indices. 9 to the power of 5. It's division, so subtract the indices. 2 to the power of 5. With brackets, multiply the indices. So it's 6 to the power of 16. Alright, simplifying with ratios. We can simplify just like fractions. So 11 goes into 11 once, and it goes into 111 10 times. Divide 44 in the ratio 8 to 3. How many parts are there in total? There are 11 parts. Therefore, one part, so 11 parts equals 44. So 1 part equals 4. So if we want 8 parts on one side, that's, and 3 parts on the other side. So we've got 32 to 12, and that should add up to be 44, which it is. Good. 5 times negative a half. Well, forget the negative for now. Half of 5, or 5 times a half, is just 2.5. And then put your negative back. Calculate minus 4 plus 2.5. So you might like to think of the number line here. That might help you. So if you're here at -4, let's add 2 and then we'll add our half. So adding 2 will get you to -2, and then adding a half will get you to -1.5. All right, convert 10 on 11 to a decimal and round to 4 decimal places where necessary. So question 6, convert 10 on 11 to a decimal. All right, how many times does 11 fit into 10? None. Line up your decimal points. So you've got 10 left over to put down here. You've got 100, that's 100. How many times does 11 go into 100? Well, 11 nines are 99, and 1 left over. Well, look, you've got 10 again. 11 into 10, 0. Same thing. 100, that's 100. 9. You can see the pattern's just going to keep going. So you could say 0.90 repeating. So is it recurring or terminating? It's recurring. All right, let's go with 298 multiplied by 2.5 45 49 14, put 0 down, 16, put 1 up there, 18, 19, 1, and then 4, 5. Add them together, 0, 15, 15, 7. Okay, now how many, in the question, how many digits are there behind the decimal point? 1, 2, 3. 1, 2. There's your decimal point, move it 3 spots. 1, 2, 3. So your answer should be 7.55. Increase 33 by 6%. So 33 multiplied by 1.06. Okay, just going back to my other question. Sorry, that should be a 4. Now, increasing 33 by 6%. Let's do it like this. 33, let's find the 6% and then we'll add it on. Okay, so I'm finding 6% of 33. 6 lots of 33. 18, 19. So we've got 198 over 100, which is the same as 1.98. So that's the 6%. It says increase 33 by 6%. So 33 plus 1.98 equals 34.98. Right, simplifying. 6 minus 1 minus 5.